Hello everyone, welcome to the session again. And in this video, we will be continuing our project on predictive analysis in diabetes data. If you remember in the last session, we have done a great implementation with respect to understanding the data part. And we have seen that one issue is there in this particular data set, which we have figured out that although this data doesn't contain missing values or null values, I would say, still it contains some weird zeros, which doesn't make sense because any human being cannot have BP value as zero, or let's say skin thickness value as zero. And at that point of time, I told you that when we will move towards the EDA step, we will figure it out. How can we solve this problem? And there are multiple things in this video you will be able to get the insights. The only prerequisite is that to understand this video, because this is going to be a long video, you should have a good understanding of stats concepts. You should have a good understanding of box plots, outliers, because this video is majorly focused on the implementation per se. And if there is anyone who is not having the idea with respect to the concepts of what is distribution, symmetric, non-symmetric, those people or those learners might face some trouble. I'll try to explain the concepts in a great detail, but still if you're having any trouble with respect to the stats concept, so at that point of time, you can apply reverse engineering. What does that mean? You can pause the video, try to understand the concept behind the stats if I'm talking about somewhere, then again come back to this video and check out the further part of the video. Okay, so this is how maybe you can learn the EDA. So let's get started. Please make sure you will watch this particular part of the video till the very end, because this is one of the most important video in the entire project part. Okay, so let's get started here. Now, before going towards the data imputation part, let's first of all understand the correlation heat map. Means how the two features are correlated. What is the significant value which we will be able to get? And the simple way is to get that is data frame, which we have created, dot core. If you just run this function, by default it will give you that with respect to the two features that we have, what is the correlation coefficient value which we will be able to get. And it's really easy to determine that, isn't it? I just have used the statistical function to calculate the correlation value between the two features that we have. Now the question which you can ask from me is that, Priya, why it is required? Why you are trying to calculate the correlation coefficient value among the two features that we have? The only reason is those who are not aware about the significance of this correlation coefficient, for them, I just want to explain to you in a very brief way. Whenever we are talking about correlation coefficient, even I'll try to create a heat map also further in this particular session itself. So whenever we are talking about correlation coefficient, first of all, do remember that its value refer mathematically how we can calculate. I'm not going into that part. If you are curious to learn that thing, maybe you can just refer Wikipedia. Everything is available there. The only thing which I want to explain you here is the internal intuition behind getting this particular values. So what I told you that the range of this correlation coefficient will always lie from -1 to +1. This is what you will observe. Now, when I'm saying that the two features are highly correlated, it simply indicates that either their value is very approximately equals to -1, or it is equals to approximately +1. And both of them indicates that somehow the two features that are available to us in a given data are giving similar kind of information to give the prediction to the model whether the person is diabetic or not. So why to take both of them? If let's say I'm saying that there is feature F1 and then we have feature F2, and let's say they are very highly correlated, maybe positively, maybe negatively. So let's say their value is, let's say, 0.97, means 97% they are giving or signifying a similar kind of a information to a model prediction, to a model prediction. So the question is that why we will take both of the features? That's the biggest question. So at that point of time, any one of the feature, what we usually do, we can remove, and that's why it is also a part of a feature selection technique. We can say it's also a part of a feature selection technique, because higher the number of features we have, which we also called as dimensions, it will take more time to my model to train. So what we want is we want distinguish information to the model so that it will be able to generate something great to us so that we will be able to get a better prediction. That's the only reason we are trying to create a correlation coefficient. Acha, when I'm saying that the range is either negative of -1 to positive of -1, so when you're saying the two features are negatively correlated, means their value is negative of, let's say, -1 or minus of 0.97. So in that case, it clearly indicates that those two features are inversely proportional to each other. Means if, let's say, you will be having feature F1 and here you will be having feature F2. So as and when the feature F1 is increasing, your value of feature F2 is decreasing. This is how the flow is going. Like this kind of a curve is there. So as and whenever your feature of F1 is increasing, value of feature F1 is increasing, F2 is decreasing. But this is something which you can say is meaning of negative correlation coefficient. Means they are correlated, the impact is negative. Means one value of the feature is increasing, other one is automatically decreasing. So if F1 is increasing, F2 is decreasing, or it can be vice versa. Then another concept is a positive correlation coefficient. What is the meaning of that? Simple meaning, I think now everyone understands this point. It will be vice versa, where you are saying that when F1 is increasing, my value of F2 is also increasing. Means somehow they're directly proportional to each other, something like this, right? This is where you are saying when F1 is increasing, my second feature is also increasing. They are correlated and that too positively manner. So this is the literal meaning of positive correlation coefficient. Positive correlation coefficient. So this is the only importance of why we are doing this calculation in the implementation part per se. So usually you will observe that the best practice will be that we will try to create a heat map of the same. So what I can do is I can create a heat map where I'm saying PLD.figure, where the fixed size, I'm just defining that figure size should be 15 cross 15 so that it will look broader and good. After that, we are using the Seaborn package to create a visualization, dataframe.core. If you can see, I'm just calling the same function which I have just defined in the above part. So you all know that this will simply create a matrix where I will be having a numbers of correlation coefficient value. After that, I'm saying annotation to be true. As of now, let's not take anything and we will see what will happen. By default, annotation will be false. We will have to make it true. I'll show you the difference between these two. After that, I'm trying to save this figure so that if, let's say, in future, I'm trying to create a presentation and I want to showcase to the clients that how will I try to decide the feature selection part, I can showcase to them. That's the only reason. And then I'm using plt.show. Now let's wait for a while and you will observe that this is how my correlation coefficient heat map is coming up with the different colors that we have. I hope it is clearly visible to each and everyone, right? So now here, if you can see, the only problem is that I don't have the values available in my chart, right? So the values are not there because I have, if you remember, removed the annotate value as true. So what you have to do, just make it like that. If you will make this parameter as true, now you will observe the difference between the previous picture and this picture. You will observe now I will be having numbers as well. Okay. Can you analyze this? So for every particular feature, you have the values available now, right? So we have for every two features, the value of correlation coefficient. And now if you will be able to see, as far as I can see in this particular complete picture, and I really want you all to also create the same with me. So you will observe that no two features have high correlation coefficient, at least in this particular data set. It means for us, every feature is important and we cannot remove any single feature for now. So that is the real indication which we will be able to get it from here. It means that when we will do the data imputation, we have to take care for each and every feature that we have. That's the only reason why I have done correlation coefficient part first before jumping towards the data imputation part, right? So this is the overall idea behind the correlation coefficient. And I hope the literal intuition behind the same is also clear to everyone. You will learn a lot of maths in this EDA, that's for sure, right? Now, another important thing which you should know or you should be aware of is the descriptive statistics of the given data. This is also very important because this usually help us to understand what is the mean, what is the standard deviation, what is the median, what is 75 percentile, what is 25 percentile, what is the count, is there any missing values there or not, minimum value, maximum value, everything you will be able to understand within one go. So what you have to do, just you have to mention data frame dot describe function, and this function will help you to understand the complete description of a given data, where if you can see now, I will be having a count, I will be having a mean, I will be having a standard deviation, minimum, maximum, and all the quartiles that we have, Q1, Q2, and Q3. Now again, if you can see, if you remember in the last video, we have talked about that how we will be able to evaluate the missing values term, where we have used the is null function, which will return the either value as true and false. And after that, because I have used the sum function, so it is giving me how many missing values are there. Another way to determine the same thing is by using this descriptive stats. How? Basically, you know that this number is there. So if you remember in the last session, we have talked about the shape, and we have figured it out that the number of records that we have in this data is 768. So what you are analyzing here, that in each and every column, I have 768 number of records. So this count parameter will provide me the number of known null values. So if let's say your data contains null values, obviously for that particular feature, the value will be less than 768. I hope it is clear. So now because it doesn't contain any null values, that's why you will observe 768 is common for each and every column or the feature that we have. Similarly, you can evaluate the mean part, standard deviation part, minimum value that we have, 25 percentile, 50 percentile is nothing but the median, 75 percentile, which is Q3, and the maximum value. So in this way, we will be able to get the complete matrix, which we can analyze it very clearly. For example, let's say you want to determine that whether your data which is given to you is in a standard normal form or not. What is the meaning of standard normal form? The simple meaning is that the mean will be 0 and standard deviation will be 1, right? So any data, if you will observe, if it follows a Gaussian format or a bell-shaped curve, it's in a normal form, right? It's in a normal form, which is having some PDF, probability density function. I'm not going into that much depth, but I'm just trying to showcase you. If there is anything you're not aware of, please do your own research with respect to the statistical part, right? So this is something which we usually say is a normal form, normal data, or you can say it's a Gaussian format, right? Gaussian distribution or normal distribution. It is very famous in statistical terms, right? Now, whenever we will be having this kind of a distribution, or you can say it's also famous by the normal distribution. Now, let's say you want to determine that whether your data is in a normal form or not, normal distribution form or not, we will try to create a distribution plot. And this is also called as a symmetric kind of a distribution. Symmetric kind of a distribution, having some mean value and some standard deviation value. Now, when I'm saying that is any data belongs to a standard normal distribution or not, the simple thing which I want to indicate here is that in that case, the mean will be equals to 0. Sigma denotes a mean part. Mean is mu, which is 0, and sigma is standard deviation, which is equals to 1. That is the literal meaning of standard normal distribution. We will discuss in future as well. Now, any data is either symmetric or it can be non-symmetric as well. For example, here we will be having either right side inclination, so right skewed distribution, because we will be having more data towards the right side, or it can be a vice versa left skewed distribution like this. This will be a left skewed distribution, right? So this statistical things will help us to determine the data imputation part now. Why is that so? I will let you know. So this is the overall idea. So we will be able to get the descriptive stats now. The next important concept is data imputation, because although we understand that missing values are not available, but we are also aware that in this particular scenario, zeros doesn't make sense, and somehow we have to handle these zeros. Now, the first way which we will discuss it in this particular session is that we can do the imputation via any of the measures, central tendency measures, which can be mean, median, or mode. Now, the question is, how is that so? And how will we determine that at what point of time which particular measure is the perfect one. For this, again, the knowledge of this distribution plots is important. Either it will be a symmetric or it will be a non-symmetric distribution. Non-symmetric distribution. When I am saying non-symmetric, it will be either a left skewed or it will be a right skewed distribution that we have. Now the question is that at what point of time you will observe a non-symmetric distribution will be there? When there will be outliers available in your data. What is the meaning of outliers? I can give you a very simple example with the help of which you will be able to understand this point. For example, let's say we are doing one survey that in Bangalore, the people who are working as a data scientist, in Bangalore, the people who are working as a data scientist, I'm doing a survey that on an average, how much salary they are earning. And let's say I went to different places and exploring the different companies like product based, service based, and figure out some numbers. So some people are earning maybe 50,000 per month. Some people are earning, let's say, 80,000. Some people, and I'm doing specifically for freshers, let's say. Only for freshers, I'm saying, because the margin should be same. We cannot compare the experienced people with the freshers, definitely for sure. So we are saying that some people are earning 50K, some people are earning 80K, some people are here earning 1 lakh as well, let's suppose, as a fresher. Some people are, let's say, also earning maybe salary as 2 lakh. And by the way, when I'm saying salary, I'm saying in-hand salary after tax deduction. Let's say I'm assuming that one. Okay? Now I met a guy in Bangalore and maybe he's working in some tier 1 company, product-based company. And he said that, let's say, I'm from tier 1 college, maybe from IIT, and I got a very good package and I'm, as of now, earning maybe, let's say, 1 CR. I'm just taking some random number just to help you explain the concept. Please don't go in a serious manner. I don't know whether this number exists or not with respect to freshers part. But by the way, what I'm saying is that this number is an outlier comparable to what other numbers we have, right? This is an outlier, can I say? So what is the meaning of outlier? Outlier simply indicates some exceptional value available within a given data that we have. Now, when I will take the average or the mean of this outlier, with the help of this outlier, this mean shuffles a lot, because now what you will do, you will say, what is the 50,000 plus you will say 80,000 plus you will say 1 lakh, right? 1 lakh plus you will say 2 lakh plus you will say 1 CR. 1 CR. Divided by, you will be having 1, 2, 3, 4, 5 terms. So this is how you usually calculate the average. And you will see, because of this outlier term available in your data, your mean shifts a lot. Your mean shifts a lot. It simply indicates that whenever outlier is there, mean is not a great measure. Whereas, if I will go for median in that scenario, how we will evaluate a median? First of all, in doing the evaluation of a median, if you remember, we firstly sort the data in an ascending order from lower to higher part. And after that, we will pick the middle value. If let's say the number of values we have is odd, we will take the average of middle values. If it is even, we will take if it is odd, we will take the middle value. If it is even, we will take the average of the two numbers that we have in the middle. So we will take the middle value now, depending upon what or how many numbers we have in a given data. Now, as it is a odd value number, because the value of n here is 5, so you will be able to observe our median is 1 lakh simply. So what you have observed from this explanation, the simple thing which I want to indicate here is that median is, mark my words, it is usually asked in lot of interviews as well. You will observe median is more robust to outliers. So it simply indicates that whenever you are dealing with any numeric data, at that point of time, whenever you are doing data imputation, so first thing, when I'm saying, let's say, whenever you're dealing with a numeric data, because we do have different kinds of data sets, right? Specifically, I'm talking about a numeric data. And let's say you want to do a data imputation because you have figured out maybe null values are there, or maybe the values are zeros, anything can happen. For example, in our case, zeros are there. That's a major issue. Now, whenever you are doing the data imputation, at that point of time, you need to figure it out what is the distribution of your data. Now, this distribution will help you to understand whether outliers are available in your data or not. If, let's say, your distribution is symmetric, in that case, though, it indicates there will be no outliers. And if there are no outliers, you can do the imputation via mean. It's a good matrix. But if, let's say, you are saying that the distribution that we got for a given feature, for a given column that we have, is non-symmetric, whether it may be left skewed or it may be right skewed, means it do contains outliers. The simple indication is outliers are there. In that case, never ever go for mean. The always preferable choice will be the median. So we will go for median and we will do the imputation via the median only. So this is how the flow will go. Let's say you will be having a categorical data. In that case, maybe we can go for a imputation with a, data imputation with a mode part. Now, how the mode will be evaluated? Basically, it depends on the frequency. So whatever be the value which is having a higher frequency, with that value itself, I will just try to do the imputation. That's it. This is the imputation via the mean, median or mode. But this is not the only way. Usually, practically, when we do projects, there can be a way where people usually apply the algorithms, machine learning algorithms only. For example, KNN is very widely used. Maybe we will discuss in the further sessions once we will be having an idea of how KNN algorithm works. So what I'm saying is, what usually people do, this is approach number 1, which we are doing it today, right? In this particular project, this is the approach number 1, which we are applying, approach number 1. But always remember, this is not the only approach that we have. Approach number could be, which we will see in the upcoming project videos, where what we can do is, we can train a model. Now, this model as of now is a black box for you, but in future you will be able to understand. For example, there is one model name is KNN. We are applying this kind of a model, and this model will give me the predictions that which particular value should be the suitable value to do the data imputation, right? In that case, we are not going for mean, median, mode. We're just trying to train a model, getting the predictions that what could be the optimal value in that place instead of 0. But this approach we are not using as of now, because we have covered up limited algorithms in our course part, right? So this is how the flow could be. So now you will be able to understand that if we want to go for approach number 1, where we are doing an imputation via mean, median or mode, we have to understand that what kind of distribution my data holds. And that is where our next discussion starts, where what we will do is, we will try to plan and see the distribution of our data. And it's very simple. We will go for Seaborn again. sns.distplot is a function that we have. Dist means distribution. So we are looking for a distribution plot. Now, in this complete EDA process, see, I am doing a recording of the videos. So it is not feasible for me to do it each and everything from scratch and show you with respect to the code part and everything. I can showcase the mindset to you, and I can showcase few things with respect to how the things will work. Then I will give you a task that now do the similar thing in the entire data that we have. This is how the flow will go, because otherwise this recording will be of 5 hours, 10 hours, which is not something I want, right? So basically, I will give you an idea, intuition that this is how you can go ahead with respect to the further task. The major thing is, in this video, I want to explain the conceptual understanding plus the implementation part per se. Definitely after that, I will give you a lead that, okay, now you go ahead, you do that part, right? So I will show you the distribution plot of few columns and will show you how the imputation will happen. Similar thing you have to do at your end as well, okay? So dist plot is the function to display the distribution plot. Now what you will do, you will say data frame dot, let's say whatever columns we have. For example, the very first column, I think we have print a list of all the columns, pregnancies, right? So let me just copy that and paste it over here. So now if you will see the distribution plot of this particular data, you can see that this is inclined almost towards, I can say, maybe we can say it will be right skewed, or you can also say it is approaching towards the normal distribution. The problem is, because of these zeros, which are here and outliers, and if we can remove them or we can do the imputation towards them, obviously we are approaching towards a symmetric distribution only. So you can either go with respect to median part per se with respect to the imputation, or you can go with the mean also. But as of now, because it is more showcasing me towards the right inclined, so I will go for the median. So what we can do is we can go and do the imputation with respect to the median part. Same thing you have to check for all the columns that we have. For example, data frame dot, let's say we will be having, I think, blood pressure also, one of the column, blood pressure. So what we will do, we will again check the particular value that we have. Again, you can see zeros are there. Can you see? In the graph itself, you will be able to understand. And once you will do the imputation of the zeros, automatically this is properly a symmetric distribution which we are seeing here. So definitely we can go here and do the imputation with respect to this BP per se. We can go with the imputation of mean. Maybe with respect to the pregnancies per se, you can go ahead and do the imputation with respect to the pregnancies per se. We can go ahead and do the imputation with respect to the median. Similarly, let's say I will go and check out the further columns that we have, which is insulin. So let's do it for that. Insulin. So similarly, what you have to do, you have to check the distribution for the entire plots that you have. Now you can see it is right skewed. It is perfectly visible to me. So definitely in this particular feature also, with respect to insulin, we can go and do the, we can say, imputation with respect to the median part only, right? This is how the flow will go. So with respect to every feature, now you know that how basically we will be able to do the distribution plot, right? It's very simple. We just have to use this dist plot function and we will be able to do that. Now the question is, so this is how now your major task would be to check each and every column that we have, for example, glucose, skin thickness, BMI, diabetes pedigree function, and age. Outcome is a thing which we don't focus on, because after some stage we will just have to remove this target column also. We will separate our input features and the target value. So as of now, just focus on this input features that we have until age part, right? So next part is that how we can do a data imputation with respect to mean or median. So for example, we will be having insulin, right? So we will be having this data frame. Now what I will do is I will take this data frame of insulin, and what I'm saying is replace. So in Python, we have this replace function. So what we are saying is replace this 0 with doing the calculation of data frame of insulin median value. Why? Because the only reason is this insulin is a right skewed distribution. So it contains a non-symmetric data. It means there exist an outliers. And that is the main reason. Just now we have discussed mathematically that whenever the outliers are there, mean is very dangerous matrix. At that point of time, we'll have to go for the median part only. And now you will be able to see done. If you want to analyze the data now, you will see or you will observe there will be no zeros available with respect to the insulin. You have just removed it, right? Can you see? In insulin, we have some values available. So there is no as such single value you will observe where I would say the zeros are there. Similar thing you have to do for other metrics as well. Now, what you can do is you can just copy these lines. I think we have 8 features available with us. 1, 2, 3, 4, 5, 6, 7, 8, right? So now maybe we can use blood pressure. So let's see the columns again that we have, data frame dot columns, and we will be able to have the list of entire columns. So we can take it step by step. Pregnancies, same code you have to use. It's just either the mean value will be there or median value will be there, depending upon whether the distribution plot is symmetric or not. So I'm just copying it up. Blood pressure, then we have skin thickness, then we have BMI, so BMI, and BMI. Then we have diabetes pedigree function. It would be great if you can just copy paste. Sometimes what happens is there will be a small spelling mistake which we usually done, and because of that it shows an error. So to avoid that, it's a good way. Now what we can do, because we already have run this file, maybe I can just separate this block with another block, right? So that it will not repeat again. So the only thing is now it is not median for everyone, right? For example, BP, I think we have planned to go for mean. So what you have to do, it's just that in case of blood pressure, just mention mean. Similarly, I think for pregnancies, we have planned only the median only. So you just have to refer median in this case. Similarly, for glucose, just uh, take out some time and check the distribution plot for the pending part. It's very easy, right? Just have to mention glucose, just write all the code blocks with respect to this part. Then we have BMI, which is pending. Then we have, I think, glucose is done, BP is done, skin thickness is pending, right? So maybe you can just copy this part, done. And then I think diabetes pedigree function is pending. So maybe we can just copy this part, pedigree function. And last thing is age, which is pending. So maybe just we can do this as well. So let's copy this and refer the age part. This is also done. So let's try to check it out, the distribution plots for every particular value that we have. So again, if you can see very clearly, for glucose, it's a kind of a normal distribution approaching towards normal. So I will go ahead with the mean with respect to glucose. So where is my glucose? Yeah, this is a mean. Now let's check the BP is done. Skin thickness plot. Let's check that. With respect to skin thickness, again, you will be able to see it's kind of, if we can replace the zeros, it's a normal distribution only. So maybe you can go with either mean or median. Maybe let's go with the median only. BMI is something which, let's go ahead. It's a normal distribution, so we can go ahead with the mean part here. But yeah, I'm doing it bit fast. You can just check it out at your end. Maybe something if I have missed, I have already told you the logic. Accordingly, you have to now take care. It's kind of a right skewed, so median is fine. And age is also right skewed, so maybe median is fine. So I think this is how the thing will look like. But definitely at your end, please check it very wisely. You just have to understand, if your plot is approaching towards normal distribution, then replace it with the mean. If it's a highly skewed one, maybe left or right, replace it via median. The reason I have already indicated you. Now you can run this. Tantana, task is done. Now you will observe, if let's say I will just show you data frame.head for the top 20 records, and if I'll just run this, you will be clearly able to understand now that we are not having a single zero available in our data, and that is what I really want to achieve. This is the first part of EDA, where what we have done is, we have done a bit of mathematics, I would say specifically statistical part, where I have shown you the descriptive stats, how we will be able to calculate, what's the significance of that. I have shown you, so basically if you will be able to observe, we have talked about the descriptive statistics and its significance. After that, I have shown you correlation coefficient part and its significance, very, very important. After that, I have also talked about distributions, types of distributions. It will be skewed and non-skewed distribution, and again its significance. Then we have talked about that mean, or I would say median, is more robust to outliers, and why, right? The reason I have stated. So this thing until so far we have covered up. So we have seen majorly with the help of this concept how we can do the imputation, how we can do the data imputation via mean and median. What is the inference we have made is, when the distribution is symmetric, we can go for mean, and when it is skewed, whether it be a left or right, we can go for the median. And let's say when the distribution is when the data is of categorical data, in that case we can go for mode, because it indicates the highest frequency. So this thing will work only for the numeric data that we have analyzed. So this is the overall idea about this session. EDA is not finished yet. I'll further discuss more concepts of EDA in the upcoming part of the session, because I think the video is too long now. So let's take it until this part. Take a note. This is the complete wrap up of this video, and I'll see you all in the upcoming video where we will do further things on the EDA part. I hope that until so far everything is clear. But still, if you have any confusion, any doubt, you can let me know. I'll see you all very soon in the upcoming video.